CATIA V5 STL to part design. So this will be a case study for a different part. Within my previous video posted 3 days ago, I made use of case mounting boss, and this is the case study model, and we have that converted within CATIA into multiple surfaces, which were later joined to a closed body. Now, for some models, this will work, but we're gonna see that for the case study model within this video, that workflow will have various problems. So this is the STL file. I already had this loaded within CATIA. I will just rapidly import that within Blender to present it. So I will go to import from the desktop, and the model will be called side. So this is the model. We see that in Blender is quite large, so I'm just going to scale it, press S, 0.001. Afterwards, I will press the dot to zoom in onto selected. And we see that the model looks like this. But if I will swap the shade smooth by angle, we're going to see the final output of the model. And we see that there are some edges that are problematic on this model. For example, we see over here in the back, we have an edge. If I will go and display the geometry wireframe on top of this, we're gonna see that this STL is splitted into some weird surfaces. Over here on the back, we see over here a vertex that is connected to multiple edges over there. And we see over here this as well. So most likely this was a model that was poorly, let's say, designed and extruded. And there are some overlapping elements. This is why if I will try to process this within CATIA, so I have this already loaded into demo optimizer. If I will go and define an offset for this, so I want an offset at 0 millimeters for the selection. I will hit save, and I'm gonna save this on my desktop as a model type. So side 1 offset. I will hit save. Now, if I will have that open, so I will load. In this case, I want to load this directly from the desktop, and I know that this will be a model type. I can also filter it over here, so side 1 offset, this will be the model. We're gonna see that this will be the master of the model. We see again the visualization, just like within Blender. This is mostly just a visualization problem over here, so I can go and copy this. I can create a new part. And within the new part, I can paste the resulting surfaces. So I can right click, paste, and we're gonna have those surfaces now processed by CATIA and upload over here. We see that the model is in red now, so this requires an update. I also will swap the workbench to generative shape design, and I will do an update so that the model will be updated. If I will remove that shading, we're gonna see that the model will look like this. So just like within Blender, we see the same edges over here on the back, which are a little bit problematic, since you can also select those, even though that area should be perfectly flat over there. Now, if I will try to join all of these surfaces, we're gonna see that CATIA will encounter some problems. If I will go over here to join, and I want to join all the way from the first one, I will hold down Shift and select the last one. If I will hit preview, we're gonna see that now CATIA will try to join all of those within a single file. But there will be various topological errors over here on the model. So as we can see, there are quite a lot. CATIA is still doing an update in progress, but you see that there are a lot of topology errors over here. So this why for a part like this that has a poor geometry, it's mostly a better idea just to start and model again. So you can just go into part design and just use this as a reference, and you can add your own dimensions. For example, we see over here that this model, when it was created, we have a cone over here, which is just overlap onto this this side. So we see again how poorly that that was created over there. The same area is visible over here. So keep in mind that this 3D model that is mainly intended for 3D printing. If I will load the same model over here within GeoMagick, so I know that the model will be this one side, I will drag and drop this. We're gonna see that GeoMagick will wanna do an analysis for this. We're gonna see that the mesh doctor will look like this. So we don't have any self-intersections or other elements. So if I will go again with mesh doctor, but we're gonna have a lot of self-intersection. For example, GeoMagick will see that all the faces over here that I highlighted in red will have some self-intersections. There are also some highly creased edges, a lot of spikes, but there are no tunnels over here. So if I will try to process this automatically with Mesh Doctor, let's say that I want to remove just the self-intersections. If I will hit apply, you're gonna see that GeoMagick will also remove a lot of geometry, so it will not be the same part. So we can use the STL to model. In this case, we see that the geometry was all, let's say, clamped up like this. So I'll just hit cancel for that. Let's see if I will to remove all the elements that are considered to be spikes. Probably something similar will happen in that case as well. So we see that for this part, we cannot use Mesh Doctor to filter that. If I will go back to CATIA, this also has the possibility to use that Mesh Doctor a little bit differently. So if I will go to Shape, Digital Shape Editor, if I will now go and import the model, so I know this will be on my desktop and will be called site. So I'm just gonna copy this file, paste over here. We have the STL. Regarding the scale factor, this, let's say I will scale like this, 1 and millimeters. And I'm gonna check the file size for this. So we see that the file size is correct because the model is perfectly overlap on the existing surface over here. So we have this side one. And just like within GeoMagick, we have the possibility to use the mesh cleaner. If I'm gonna analyze this, we're gonna see that CATIA will only find one manifold vertex over here. So other than that, there are no problems with this STL. But still there are problems because we cannot automate the transformation from STL to part body part. This is why I recommend Fusion, because I have the same mesh over here processed. We see the whole video is 2 minutes. Starting from having that model loaded over here. Afterwards, within mesh, we're gonna do a mesh face group. After that, we're gonna see the grouping of those faces. And later, we are gonna convert this to a solid part, solid body. Let me just start that. So we see this is the converted model. And within Fusion, if we want to do some reverse engineering on top of that, we can select those elements. But as you can see, we need to select all the triangles, since that top face will be still defined by some triangles. But we can go and later have that extruded. For example, over here, I extrude that on a distance of 3 millimeters. And the same can be done for others. So in this case, Fusion can process this a lot better than CATIA, as we can see. But for much more simpler parts that don't have a lot of problems and self-intersections, you can use the workflow presented over here, because this was a cleaner model. We see the final output was defined by those 4 surfaces that CATIA managed to join without any problem, and afterwards we can define that close part for this. And later we can use a similar workflow to part design to do some changes to the model. Okay, so I hope you find this video useful. I will position a similar video on the left side and a subscribe button to the right. So that's it. Thanks for watching.